Hello and welcome to the second video of Quick Solutions. The topic of this video is creating and querying real-time customer profiles. We will show you how, with the help of Quick, you can build customer music profiles that not only have charts with top artists, albums and tracks, but also store this data for future music recommendations. Consider the following example of a music streaming service. Every time a user listens to a song, an event is emitted and written to a Kafka topic. These listening events can look like this. In such a music streaming service, we may want to analyze general metrics such as overall count of events, the last time a user listened to a song, or the user's top 10 artists. Let's start by querying those first metrics. We have a user with this ID, and we query his user profile for the total listening counts, first listening event and last listening event. Here this is shown with a timestamp. As a part of this customer profile, we can also query the user's top artists. We specify the fields we want, like ID, count plays, and the artist name. What we get is a list of the user's most played artists. They are sorted by count plays and have the ID and name. Let's see how we can build this streaming service with Quick. The first thing we should always start with is creating a Quick context. We need a Quick host and an API key. I will use demo d9p.io as a host, and I have copied the key, but you cannot see it right now. For more information about Quick and how to get started, visit our website www.d9p.io. Next, we will need to create a so-called gateway to apply our Graphql Schema and query all the information we saw earlier in the video. We create a Quick gateway with the command quick gateway create, and we specify the name, that is profiles. Next, we should define the Graphql schema that we want to apply to this gateway. It looks like this. First, we have a type query that is getUserProfile. We have the argument user ID, and this returns a type of user profile that has all of those 6 fields. The first 3 are simple. They have total listen count, first listen event, and last listen event that all return type long. And then we have the more complex types that are the artist, album, and track charts. The artist charts, for example, return named artist charts. This is a type that returns a list of named artist count that consists of ID, artist, and count plays. And this artist is of type item because all 3 of them, the artists, the albums, and the tracks, use this type item, and they have ID and name. We also have other types like listening event and charts and chart record that don't have also the name in them. We will use that later for creating some of the topics. We apply this schema to the profiles gateway with the command quick gateway apply, the name of the gateway, and we specify the file with the schema. Next, let's create the main topics that will store all of the albums, artists, and tracks information, and of course the topic listening events that we will use for every Kafka Streams application. The Graphql schema for all 3 topics, albums, artists, and tracks, has this format of type item that has ID and name. To create the topics, we will use the command quick topic create and the name of the topic. For this example, artists. Then we should specify the key that is long and the value that is the schema that we can also get from the schema we applied to the gateway profiles. So we should write profiles.item. That way the data in the topic will be in the same format that you see above. The method is the same for creating all of those 3 topics, albums, artists, and tracks. So now let's create also the topic listening events. This is the schema that we should use for creating this topic. It has a type listening event that consists of user ID, artist ID, album ID, track ID, and a timestamp. We create the topic listening events and take the schema from the gateway. Next, let's create the simple quick applications for counting the listening events and finding the first or last listening event. We already have our input topic, but we do need to create the output topics for these apps. All three of them have the same data format, long, so the command is as follows. Then we will need to deploy the quick apps for these output topics. I will take for an example the first listen. We specify the registry, the image name, version, and the arguments that are input and output topic, as well as, in this case, the kind of the app, which is for finding the first listening event. Productive is set to false. For more information about how to create Kafka Streams applications like this, look our Streams Bootstrap repository. For counts app and last listen, the commands for creating the output topic and deploying the app are the same, only with changed names. In the counts app, there is no argument kind, and for the last listen app, kind is set to last. Let's continue to the more complicated applications that make the music charts. We will again use listening events as an input topic, but we will create the three output topics: top albums, top artists, and top tracks. The Graphql Schema is the same for all of them, and it looks like this. It is of type charts that have a list of chart records, and these have only the ID of the corresponding album, artist, or track, and the number of times it was played. In this schema, the name is not included. When we want to query it, we will see the name of the artist, for example, because of the schema we apply to the gateway that connects those ID to the artist topic and resolves the name. We created three topics with this command. I will show this for top artists. And then we deploy the corresponding quick application the same way as before, with quick app deploy top artists. This time the image name is user charts, and as arguments there are the input and output topics. What that app does is finding the most listened artists of an user, comparing the count plays. When creating such a music streaming service, it is good to consider implementing user recommendations. We can also do that with the help of Quick. We want to query artist recommendations when inputting a specific user ID. And we get a few artist suggestions with the artist's name. We know for a fact that this user hasn't listened to these suggestions. How do we integrate such a recommendation service in Quick? First, we should add this recommendation query to the Graphql Schema applied to our profiles gateway. As you can see, here is the getArtistRecommendation query with a few parameters we should specify. The user ID is mandatory, and for example, the field here is set to artist, but it can be also album or track. There are also 4 optional parameters that come from the Salsa algorithm that is used for this recommendation service. They are already set by default. This query returns a recommendations object that is connected to our custom REST directive. This REST directive basically returns the suggestions of the algorithm under a specific user ID. As you can see, the URL here is under http:/recommender/recommendation, and then the path parameter is user ID and field. So in this case, we take the specific user ID and the field is set to artist. So what the query returns is the recommendations type that consists of a list of objects of type recommendation. And in the recommendation, we can see there is an ID and an object artist that is connected to the type item that I talked about in the beginning. And this is connected to the right topic, and it is resolved by this key field that is the ID. We will apply this improved schema to our gateway. In order for this whole recommendation service to work, we deploy the recommender as a quick app with the same parameters you saw before. We only add port 8080 where we can see our custom REST directive. We do not need an output topic. Now let's go to the browser and see the output of this REST directive. This is the URL and we have specified the user ID and the field that is artist. It returns the recommendations for this user, but only the IDs of the artists. When we query them, they are mapped to the corresponding name again because of the Graphql Schema we applied. We can also change the field to album or track. The whole architecture of this project can be visualized like this. We have the topics in this neon green color, and you can see that the topic listening event is an input topic for all of these quick applications that we created. Here you can also see all the output topics that match the apps and the recommendation service. They are all connected and processed by our profiles gateway. On the left you can also see the three topics: albums, artists and tracks, and they are important because they help resolve the right names used, for example the recommendations where we get only the IDs, and with the help of the schema we match that information. In this video we showed you how to create and query customer profiles in real time with the help of Qwik. For more information, watch our other videos or follow the tutorials in our Qwik website www.d9p.io. Thank you for watching.